One of the most important things to do when building on top of a new system is to consider the correct database technology. We have many different categories from SQL to NoSQL to emerging to analytics platforms. Let's first take a look here at SQL. The idea here is that you have a relational model with fixed schemas. You can do ACID transactions. So the idea here is that you do care about consistency and you have complex joins and aggregations. Some of the examples here are MySQL, Postgres, SQL Server. Now, a little bit of a wild card here is SQL Lite, which is a standalone database that can handle huge data, a third of a petabyte of data, and it's often used in mobile apps as well. And it could be really useful for data scientists to do standalone projects. Next up here, we have NoSQL databases. They're flexible. You don't have to worry about the schema. They're also focused on availability and scalability. So in the CAP theorem, where we have some trade-offs, right, between consistency and availability, in this case, we care about availability more. And so these are eventually consistent data sources. And there are various data models like the key value model or the document model or the columnar model, and they depend a little bit on which database. Some of the examples here, Mongo, Cassandra, Redis. Now, we also have these emerging databases that are very interesting because they give you new properties. So a graph database is one of the forms of new databases here, and you can see here that you can store data in nodes connected by edges. You also have the ability to do optimizations for connected data like social networks. And you also have very powerful traversal queries. Some of the examples are Neo4j, Neptune. And what I think is personally a very exciting part of them is this new kind of descriptive statistics like centrality, PageRank. You're able to look at different ways of communicating about data because it's in a graph form. Just like you'd have descriptive statistics like the median in a traditional data set, when you look at a graph database, things are much different. We also have vector databases, and vector databases are very interesting in that they have the ability to really dive into different kinds of data sets. So for example, if you wanted to do a recommendation engine, this could be a great choice because you could instantly figure out the correlations between all of the features you have. Also, if you wanted to do things around any kind of machine learning problem, you could usually use these things to optimize some of the workflows. So they're also an emerging option for many new machine learning use cases. And then finally, we have analytics workflows. And with this, we have, really the two big contenders are Databricks and Snowflake. And if we look at what they do, it's columnar storage that's optimized for analytics, in-memory caching speeds and queries, also advanced analytic functions. And some of the examples, again, are Snowflake and BigQuery and Redshift. They all have these capabilities of doing analytics as a platform. And some of them are cross-cloud in the case of Databricks or Snowflake.